All right, so today I'm going to go over how to calculate the Q values for nuclear reactions. So what is a nuclear reaction? A nuclear reaction usually occurs when a nucleus is hit by another particle or a gamma ray, which gives us enough energy to cause a reaction. In a nuclear reaction, we usually have transmutation, which is just the conversion of one element to another element by decay or nuclear reaction. So one nucleus is going to turn into another nucleus. So when we write down a nuclear reaction, we can write them in two different ways, as is shown below. So on the left side, we have what's coming in. So in this case, I have an alpha particle hits a nitrogen nucleus, and it turns it into an oxygen nucleus plus a hydrogen. Or just actually, there's just a proton, right? A hydrogen nucleus is one proton. So it's got one proton, one nucleon, so 0 neutrons. So what we have is a proton coming off and an oxygen nucleus created. So another way to write this, as opposed to just the sort of normal what you would see in chemistry class for a chemical reaction, is the way shown at the very bottom. So you write your initial nucleus and your final nucleus on either side, and then you put brackets in between and you write in what hits it, an alpha particle, and what is emitted, a proton, in between. So you can read this as a 14-7 nitrogen nucleus is hit by an alpha particle and it emits a proton, and it turns into an oxygen 17 nucleus. And just like we had for our radioactive decays, electric charge, so the subscript has to be conserved, the nucleon number, the superscript has to be conserved, and the energy and the momentum have to be conserved. So when we have a nuclear reaction, it either takes energy to make it occur or it releases energy. So the reaction energy, or the Q value, is just going to be the mass change between the two sides of the equation. So it's the initial mass minus the final mass times c squared. And it's important that you get them in the right order. You do what you start with minus what you end with, so that we can tell whether it's an exothermic or endothermic, whether it releases energy or it absorbs energy. If the Q is positive, then this reaction is spontaneous. It's going to occur regardless of whether you have an initial energy of the particle that comes in and bombards it. If Q is negative, then it's endothermic. So it needs to have that incoming particle to have a certain amount of speed, a certain amount of kinetic energy when it hits the other nucleus in order to cause the reaction to occur. And the threshold energy is that minimum amount of kinetic energy that's required to cause the reaction to occur. So if we want to calculate the Q value, we're going to just follow that rule. We do mass on the left minus the mass on the right times c squared. So for this example, I have a tritium nucleus and a deuterium nucleus. So those are hydrogens. They both have one proton, and one has 3 nucleons total, one has 2 nucleons total. And that turns into helium plus a neutron. So we want to do the calculation where we take the mass, all the masses are given there, remember we don't do any rounding, and we do the mass on the left minus the mass on the right. So let's do that. So Q is equal to the mass of A. A is my tritium, 3.01060 U, plus the mass of the deuterium, 2.0141 U, minus the mass of the helium nucleus, so 4.0026 U, minus the mass of a neutron, 1.0087 U. When you do a problem, again, remember, always use the total number of digits that are shown in whatever the source is in the problem, or you'll probably be told you have the wrong answer. All right, so I'll put my c squared at the end. If I put all those numbers in my calculator, I get plus 0.0188 U times C squared is my energy. The positive tells me that that is exothermic. This is a reaction that's going to occur naturally. It doesn't need to have any initial kinetic energy of the incoming particle. How do I turn this into something that looks like an energy? Well, we're going to do the same thing that we did when we calculated binding energy. We're going to use that 1U is 931.5 MeV per C squared. Okay, so I'm going to do 0.0188 U times 1U is 931.5 MeV per C squared. And I'm going to multiply by C squared. So my U's cancel out, the C squareds cancel out, and I'm left with just units of mega electron volts. I get 17.5 MeV. Okay, so just remember, all you do for calculating the Q values is you take your mass difference, multiply that mass difference in U times 931.5, and that will give you the energy in MeV. So this is an exothermic reaction. So what I want you to do today is just calculate. I've got all the masses down at the bottom for each of these two reactions, A and B, what the Q value is, and are they endothermic or exothermic. I'll give you a hint. One is endothermic, one is exothermic. So you need to make sure you put the Q calculation in the right order. So you put the reactants are positive, you subtract the product masses times C squared.